back to our channel. So in the previous session we have discussed about the introduction to normalization and why we are moving towards the normalization. So normalization is mainly used to avoid the redundancies and to overcome the problems coming from the anomalies. That means while inserting the data, updating the data or deleting the data. And as we discussed in the previous session, so this normalization comes with the different levels. So coming from the 1NF, 2NF, 3NF, Bcnf, 4Nf and 5Nf. These are all called as a normal forms, right? So if any relation or any database, okay, so which satisfies up to the third normal form and the Bcnf, that implies the database design is a good design. The schema is a good design, right? So in this session, we'll start with the first level, that is 1NF. So from the unnormalized data to 1NF, how can we convert or how can we know that whether the relation is in 1NF or not? So 1NF. So this is also called as first normal form. First normal form. So the input for this one is unnormalized data, and output will be relation with 1NF. Relation satisfies with 1NF. So that will be the output, right? So we'll see how we can say the relation is in 1NF, right? So the first point, all the attribute values should be atomic. So that means it should have a single value, and attributes should not have multi-valued attributes or multi-values or composite. That means the attribute can't be divided more, right? Composite, right? And all the attributes should be unique. So no two attributes should have a same name. So that type of redundancy should not be accepted in this 1NF, right? So the first one, all the attribute values should be atomic, and attribute should not have any multi values or a composite. So every attribute should have only single value, and all the attributes should be unique. So there should not be redundancy on the attributes. So all the attributes should be unique. No two attributes should have the same name. So if any relation satisfies these 3 points, we can simply call it as a 1NF. So we can say the relation is in 1NF. Let me tell you an example. This is a very simple normal form. So let us take the student details, student table with a student ID, student name and course related to that particular student, okay, enrolled by the student. So let it be some 101 is a ID, Sundeep is a student name. So Sundeep enrolled to C++, Java. So one student enrolled to multiple courses. Next, coming to the second one, 102, let us take the name of the student is Saradhi, enrolled to C++, Python. And Python. Let us take the third one, Satvik, enrolled to Java, Python. Now let us check whether this particular table, so this is a primary key. Let us check whether this table satisfies the 1NF, the points we have discussed just now. The first one, so it should be having atomic values, yes. Second one, it should not contain the multiple values or a composite values. So all these two are not a composite, and this is also not a composite. So composite means further divided. Okay, if the attribute is furtherly divided, so we can say it as a composite. And C, course, there are multiple values for the particular course. So C, C++ and Java. And it violates the second point. It should not contain a multi-values. So we have to avoid this one. So how can we avoid this one? Simply we can include another row with this particular details. Okay, so that will avoid the multiple values. And all the attributes should be unique. So there are no two attributes with the same name. Yes, that's satisfied. So only one point that violates the 1NF is multi-values. So this can be converted to yes ID, yes name, and a course. And you can see 101 Sundeep enrolled to C, 101 Sundeep enrolled to C++, 101 Sundeep enrolled to Java. Similarly, 102 Saradhi enrolled to C++, 103 Saradhi enrolled to Python, and 102 itself, right. Next, 103 Satvik enrolled to Java, 103 Satvik enrolled to Python. So you can observe this is the table which satisfies all the points which we have discussed for 1NF. So this is the table. Now you can see we have converted this type of relation to this relation. Now you can see there are no multi-valued attributes, right? So none of the attribute is having a multiple values. So in order to avoid that, if we are having this one, in order to avoid that, just insert one more row. Okay, insert one more row. So like this we can avoid the multi-values. So every attribute is having only one value. Every cell is having only one value, right? So this, if the relation is in this form, we can say this is in 1NF. That is a first normal form. Okay, this is unnormalized relation. So this is the relation with 1NF. Relation in 1NF. So from here we need to go with the next levels. So coming to the 2NF, if you want to find out whether this relation is in 2NF, so first it should satisfy the 1NF conditions. That means the input for 2NF is the relation with 1NF. Okay, the input for 2NF will be relation with 1NF. So input for this 1NF is unnormalized data. So from that we have to achieve the 1NF, right? So hope you understood this first normal form. So let's stop here. In the next session we'll go with the another level, that is a 2NF, right? So if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.